Hey everybody, I am going to redo the first problem from chapter 1 of Classical Mechanics by Goldstein. I just need to find it really quick. And it's a derivation, and it says, so there's two parts to it. The first part is it wants you to derive that the time derivative of the kinetic energy is equal to force. Let's take these suggestions off. Come on, off. There we go. Force dotted with the velocity. Okay, and so to do this, all we're going to do is simply do the derivative. So the kinetic energy is equal to 1/2 mv squared, which we can also write as, so I'll take the 1/2 m out, and then we have a dot product, v dot v, and then when you have this dot product, when you're taking the time derivative, you have a power rule, so equals 1/2 m times v dot is the time derivative of velocity, v dot v plus v dot, and these are the same thing, they commute, right? So this is equal to 1 m v dot v. And what is v dot? V dot is our force. That's equal, v dot equals a, ma equals f. So we can rewrite this as f dotted with v. Simple as that. So we have our first derivation, and we'll just set this equal to that. And then the next one is, it asks you if mass is time differentiable, meaning that it is not a constant, then we can't take it out of the derivative. Then how do we show that the corresponding equation is this with an extra m? So they added an m, which will, the reason shall become apparent here in a second. Show that that is f dotted with p. Momentum. Okay, so this one, instead of breaking it up into velocities, we're just going to keep it as momentum. So recall that the kinetic energy is also p squared over 2m, right? Because p equals mv. Okay, so in that case, this derivative is m times p squared over 2m. It's this derivative. And you can see immediately the m's cancel, so we get 1/2 out front, and we get the time derivative of p, which is a vector dotted with p. And this, again, it's the exact same thing, but instead of v's we have p's, so we get p dot p, so 1/2 p dot p plus p dot. Haha, I said pp. Anyway, yeah, so this just equals 1 p dot p, because they also commute. And what is p dot? That is our friend ma. Yeah. This is force. So force dot momentum is our final answer. And so therefore all right, and that is it.